Additive manufacturing is not a new technology. In fact, it's been around for many years, but with significant barriers to entry. I'm here in Rugby today at HK3D, and they've actually launched a new printer. It's the Metal X from Markforged, and I'm told they've significantly reduced the barriers to entry. Steve, today is day one of a three-day event, the launch of the Metal X. For our viewers, maybe you can give us a brief introduction.
Yeah, of course, yeah. So we've been working with Markforged for a couple of years now in the plastics side of things. People would know it as an FDM process. Markforged have launched a brand new product which combines FDM process and metal injection moulding, pulls them together. It's called the Metal X. The process is called ADAM, Atomic Diffusion Additive Manufacturing. And basically what we do is we take the FDM process, we have a material which is 60% of its metal type, 20% of its wax, 20% plastic, and it's laid down layer by layer and built up. So we take any CAD file and we bring it into our proprietary software IGA, and through there we basically can send it to any of our printers. The printer immediately starts like any other 3D printer. This time of course it's laying metal down. Once that process is complete, the part is taken off. We instantly put it into a cleaning process, which takes anywhere between 7 to 10 hours. And then once that's complete, the part is then removed from there and put into the sinter station, which takes around about 20-25 hours, depending on the parts and the volumes. The beauty is it can be batch done. So we have multiple parts, all printing at the same time, multiple parts going to the cleaning system, and as a result, the sinter station. And the key thing is there, Joe, is the fact that we haven't got a hands-on process. I haven't got to remove those supports by hand. They break away very easily. And the only machining processes that you may be involved in is that if you actually wanted to finish a hole, drill, tap, or anything below an M3 type thread, that you actually want a high accurate surface or surface finish.
How come there's no support material?
So there is support material. Support material is just basically divided between the support of the part with a ceramic layer. And once it comes out the sinter station, a quick tap and the ceramic layer breaks and comes away from the support base.
So additive manufacture, it's not new at all, but there's been lots of barriers to entry. In fact, we've just talked about them in your presentations. How have you overcome these barriers to entry?
Well, we looked at that in detail today, and we understand that, having worked with powder laser metal systems for a number of years, we're certainly not standing up here today starting to knock that process whatsoever. But we also understand those barriers, be it the health and safety factor with the powder, be it the changeover materials, be it the cost of the product, are all limitations. One of the big areas is also the design. There is a real requirement for laser processes, powder processes, to design the product around those parts. With Metal X, that kind of changes. We get an entry point of a machine of sub £110,000. We can change materials in a matter of minutes, so I can go from stainless to titanium very, very quickly. But also the design process. I mean, we spoke about parts today. This is being one of them. Why would we design a brake lever and print it? Well, traditionally you wouldn't do it. But with the Metal X, we can actually change the infill structure to a 50% reduction, gaining around about a 30 to 40% weight saving, instantly without having to change the design. That doesn't mean we don't change the design. That don't mean we don't look at the parts and get them working well for the process, but it just means it's less of a barrier to entry, really, Joe.
So the big thing for me is this material change. How have you gone from days to minutes?
So basically we're not working with a powder anymore with this process. We're working with a reel of material. So the stainless steel in this case, 17.4, gets delivered on a reel and it gets fed through into the machine. Now if a customer decides that they want to then run aluminium, they can literally rerun that feed back and put the aluminium into the machine.
The other thing is, you go to a university, you get qualified to run these machines, and then you've got to put all your smock on, your glasses, your breathing apparatus. Does that disappear with powder as well?
Without the powder, yes. I mean, we haven't got that issue of dealing with 5 micron bead diameter, powder, of course. There are still some health and safety factors to take into consideration. And that's hence why we ask people to come to Rugby and come and see the process, so they can understand the sinter station and what's involved in that post-process. But certainly from a printer perspective, the printer can sit in any office environment and print metal parts.
How about the rest of the environment, the cinder station and things like this?
Yeah, so we work with BOC directly, the gas supplier, so we offer a turnkey solution for our customers. They don't want to have to worry about gas supplies and all those sorts of things. We can deal with that for them. The ratios of the argon going into the machine are all taken care of by our system.
But in terms of applications, we've got lots on here, but where do you see it? Where do you see the fit?
So really, I think the first and foremost, we would look at basically people that are looking to reduce weight of their part. We're looking at parts that are going to be produced in the hundreds, not the thousands, and also parts that are no bigger than the size of your hand. Anything kind of fitting within them parameters is a starting point for us.
And I must add, great presentations. You've got a good team here, haven't you? Been in the game a long time.
They have. Generally all come out of an engineering environment as well, which really helps when we're engaging with our customers. So now we have got a really good team, and the whole idea there is the fact that they can actually go one-to-one with our potential customers and understand their challenges.
I think that's important. You can go to online stores, you can buy 3D printers of any value nowadays, but you're not going to plug it in and press go, are you? There is some value added to be had to having application engineers.
We've already had our engineers being sent over to Boston, and it's interesting because some of the Markforged engineers are very interested in some of the things that we're doing. So it's working both ways with us, and you're absolutely right. We're not about selling these products online. We are about engaging with our customers, going through the process of understanding their challenges, and hopefully coming out the other end of it with us both happy in the view that we can supply a machine that ultimately fits the right purpose for that business.
And just finally to conclude, I don't like talking price on any product because it's about the product itself rather than the price. But that's a big sell, isn't it?
It is, and it has to be highlighted because the whole idea about what you've seen today's presentations is that this product is really about hitting those small to medium businesses, and with that has to come the right price tag. So for around about £110,000, we have got a turnkey solution with your customers being up and running for that.
So Steve, it's been a great day, I've been fascinated, but if I'm an engineer watching this video, how do I find out more?
Yeah, so of course make contact with us, through our website. We've got more events coming, Joe. So in October we're going to have an academia focused event, and of course we're going to have another one of these running as well for all the engineering companies that are interested. But the truth is the doors are open here at HK 5 days a week. The system's always here, always running, so we welcome anybody that wants to come along and see the whole process, to make contact with us, and we'll basically make space for you and make a way to tap into our engineer excellence.